Hello everyone. Today we are looking at the question Leetcode 167 to sum 2. So what is the question? We are given a one indexed array of integers number that are already sorted in non-decreasing order. We need to find two numbers such that they add up to a specific target. For this given example, we are given an array of four integers 2, 7, 11 and 15 and we are given the target 9. We can find that the two elements 2 and 7 add up to 9 and therefore this is the answer. For this example, we are given an array of 2, 3 and 4. The target is 6. Okay. Oh, sorry. We have to return the position of the integers. Here 2 and 7 added up to 9. We have to return the position of 2, 1 and position of 7 that is 2. And here 2 and 4 add up to 6. Therefore, their positions are returned. Okay. Uh, so let's take this example. We are given an array of 5 integers 2, 7, 11, 15 and 27 and the target element is given as 22. Now we know that 7 and 15 add up to 22. How can I know that? How can I find this element? The first approach is the brute force approach. Okay. What we will do is we take two nested loop. How? Let's take an I pointer here and a j on the next to I. Now we check 2 is 2 plus 7 equal to 22. No, therefore we move the j pointer to the next element. 2 plus 11 equal to 22. No, therefore we move the j to the next element. 2 plus 15 22. No, therefore we move j to the next element. 2 plus 27 is not 22, therefore we move j to the next element and it has come to the end of the array, therefore we move the I pointer now. Okay, we move the I pointer. Now again put j next to I. Is 7 plus 11 22? No, therefore move j to the next element. Is 7 plus 15 equal to 22? Yes, therefore return the value of I and that is 1 and return the value of j that is 3. Therefore 1 and 3 is returned. Now how can you do it? So I have already written the code to take input and we should print this vector also for I equal to 0, I less than n and set of size I plus plus cout. Okay, so what we are doing is we are taking the size of the array, then declaring a vector, taking input of that vector, taking input of the target variable, creating a answer vector where the two elements will be, that means the positions will be returned, and calling the function. So we need to write the function now. This will return a vector, that means the return type will be vector also. Vector int to some vector int a and the target int target. Okay, so for the brute force we are taking two loops for int I equal to 0, I less than uh, a dot size minus 1, as it will uh, move only till here for so that j one j can be placed here so that two minimum two elements can be added. I hope you understand that, and therefore I plus plus. Now the j loop for int j equal to, we are placing the j next to I, therefore j equal to I plus 1, j less than a dot size. Okay, then j plus plus. If a of I plus a of j equal to target, we were returning I comma j. And as this is a return statement, after returning from here, this will not check for any other elements and terminate from the function block. And if this value is not returned, like previously, j will be increased, and if j reaches the end of the array, then I will be increased one by one. And if nothing is returned from the two loops, then we will return -1 comma -1 as an edge case. So there are let me take the input 5 elements: 2, 7, 11, 15, and 27, and the target is 22. Let me run it. So position number 1 and position number 3, that means position 1 and position 3. But the question was that it is a one indexed array, so we will return I plus 1 and j plus 1. That will give us the correct output according to the question. So this was the brute force approach. Now that was the brute force approach, taking n square time complexity. But we can reduce the time complexity by a better solution using binary search that will take total of n into log n time complexity. Okay, how? Let me put I first here. At the position I, a of I equal to 2, we found one element. Now we need 22 minus 20. We need to search that if 20 is present in the array, rest of the array or not. As it is a sorted array, we can apply binary search here and search for 20. If 20 is found, then we should return I and return the middle. If 20 is found, then we can return I and the position where 20 is found. If uh, for for in this case 20 is not found in the array, therefore we will move I a of current a of I is 7. Now we need to find 22 minus 7, that is 15. We need to find 15 in this part of the array using binary search as it is sorted. We can find 15 here, therefore we will return the value of I and position of 15. So how the code will look like? The code will be simple. That means for I equal to 0, I less than, again n minus 1, I plus plus. This is the working of the I, that loop that will run until the before the last element, so that one element can be searched using binary search. And then we found, let's take x equal to target minus a of I. Therefore, we need to search x in the rest of the array. That means from I plus 1 to n, we apply binary search. Okay, so the time complexity of this loop is n, and time complexity of binary search is of log n. Together they form big of n log n. You can try this code on your own. I will put the code in the description box if you need to see. But for now, we will move directly to the optimal solution that will take only big of n time complexity. Now we move to the optimal solution. So what we do is we put a start pointer here and we put an end pointer here. We found we check the sum of these elements a of s plus a of e. We find that this is now 29 currently. This is greater than 22. 29 greater than 22. As the array is sorted, we can observe that if we move the end pointer to the previous element, the summation will be reduced. Therefore, we move the end pointer to the previous element. Now, a of s plus a of e is equal to 2 plus 15 is 17. This now is less than 22. Okay, so as you can guess, to increase this sum value, we need to move the start pointer to the next value. Currently, 7 plus 15, we get 22, and that is 22. Therefore, we return the value of s and the value of e. This is how the optimal solution is created. The time complexity will be big of n as we are taking a single loop. Okay, so how to code it? Let's go to the Leetcode and check. We are taking int start equal to 0 and end equal to numbers dot size minus 1 to keep the end pointer at the last element. Okay, so what we do is while start less than end, this should not be less than equal to, as we are taking at least two elements, so when start and end will become same, we will not have two elements, therefore we have to have at least less than end. What we do is if numbers of start plus numbers of end equal to target, we need to return start comma end. Okay, if this is the case for equal, else if let me copy this phrase. If the summation if the summation is greater than target, if the summation is greater than target, we need to move the end pointer to the one step back. Therefore, end minus minus, and else, that means if the summation is less, then we need to move start to the next element. Okay, this will if it founds some equal to target, then it will return this statement. And if in the whole while loop nothing is found equal, therefore by getting outside the loop, we will return -1 and -1 as an edge case. Okay, so let me run the code and check for the sample test case. So the mistake I did was I put a point instead of a comma. And another thing to keep in mind that this was one indexed array, so we should return start +1 and end +1. Now let's run it and check the sample test cases have passed, and let's submit. Yes, it is accepted. So thank you for watching, and if you find this video helpful, please subscribe to the channel. Thank you.